This is Advanced Math 12.5 Notes. That's Advanced Math Unit 12, Lesson 5. You should have your notes out, starting to label. The title is Change of Base Theorem and Half-Life. And you put the date in the upper right-hand corner. And you should also have out a scientific calculator, whether you've borrowed one of mine or you have your own. All of this should be out on your desk. Again, the title is 12.5, Change of Base Theorem and Half-Life. And we are going to solve. All right, number 1, log base 5 of 30 equals x. Log base 5 of 30 equals x. And I did tell you guys last week that, well, let's rewrite it first. How do we solve this? This is drop the log or wrap around. Because there's not a log on each side, you are going to wrap it around. 5 to the x power equals 30. That's how we wrap it around. 5 to what power equals 30? Now, last week I talked to you guys about we're going to eventually reach some that I cannot get to the same base. 5 to the first is 5, 5 squared is 25, and 5 cubed is 125. So I cannot get 30 to a base of 5. It's just not going to happen. Yes, it's 5 times 6, but it's not 5 raised to a power. So what do we do when we cannot get them to the same log? What we're going to do, to start with, we're going to take log of both sides. So you're not multiplying both sides, you're taking log of both sides. Okay, so I'm not multiplying by log, I'm taking the log. It's going to look like this. Log of 5 to the x equals log of 30. Now, because I'm choosing to take log of both sides, I could pick any base I want. Log base 2 of 5 to the x equals log base 2 of 30. Why am I choosing base 10? Because we're eventually going to plug this in our calculators, and so I want it to be base 10 because that's what the log key here is programmed with. It's also programmed with the base of e here, but I'm going to use base 10. Okay, so log base 10, I don't have to write the 10, of 5x equals log of 30. Now, the reason I'm doing log of both sides, the whole reason is to be able to get this exponent here down as a coefficient so I can solve. I don't know how to solve it here. I can't get them to the same base, so at least this allows me to take the x down as a coefficient. All right, and now I'm trying to get x by itself, so what I'm going to divide both sides by is the log of 5. That would cancel out there and here. Logs do not reduce, and I cannot reduce the 30 and the 5. Yes, they do reduce, but when it's written like this, I cannot, should not, will not reduce the 30 and the 5. I'm actually going to plug this in my calculator, and we're going to round to 3 decimal places. All right, so get your calculators ready. And we're going to type in log of 30 divided by log of 5. Okay, I have it on, I have it cleared. Log of 30, make sure you close parentheses like we used to when we were dealing with the sine problems, sine and cosine problems. Divide by log of 5. And again, you don't have to close the parentheses in the denominator, but you do in the numerator. Log of 30 divided by log of 5. And we get 2.113. All right, number 2 is log base 12 of 7 equals x. All right, so I'm going to rewrite it. 12 raised to the x power equals 7. I cannot get these to the same base, 12 and 7. Oh, sorry, didn't realize it was off screen. So I'm going to put that in. That's log base 12 of 7 equals x. I wrap it around. 12 to the x equals 7. I cannot get them to the same base. So what can I do to get the exponent down? I take log of both sides. Log of 12 to the x equals log of 7. All right, and the whole reason I do this is to be able to take this exponent down as a coefficient. X times log of 12 equals log of 7. Then I'm going to try to get x by itself, so I'm going to divide by log of 12, gone. That's going to be what I plug in my calculator, making sure I remember to close the parentheses. Log 7, close parentheses, divide by log 12. And 3 decimal places, 0.783. All right, so what we're going to do is see if we can use this to figure out what the change of base theorem will be, because that's what the title of the notes is, change of base theorem. Okay, so change of base theorem. Okay, so when I have something like this, log base 5 of 30, this is the work I do, and this is the answer I come up with. Now, what we're trying to do is figure out a shortcut. So when I have this here is what I plugged into the calculator. Log of 30 divided by log of 5. Log of the of piece, log of the A piece divided by log of the B piece. Let's see if that happened over here as well. This was the problem, and that right there is what I plugged in my calculator. Log of the A piece divided by log of the base, the 12 piece, the B. Log of A divided by log of B. It worked there as well. So that is going to be, instead of doing all these steps, personally, I prefer these steps. On something like this, I would use change of base, but we get to harder ones, I do like doing it this way. But on easy ones like this, I would suggest using the change of base. All right, so it is log base B of A equals log of the A piece divided by log of the B. Now this, because here I'm not writing any base, that means my base is 10. Why do I want to have a base of 10? Because that's what my calculator is programmed with. Now let's just test it really quick. Log base 2 of 8. That one we know 2 to the 3rd power is 8. So we know that answer is should come out to be 3. But if we did change of base, it would be log of 8 divided by log of 2. So right now you're not going to have them this easy. Right now we're just testing that this change of base works. So let's test it. We know the answer should be 3. We're going to test log of 8, close parentheses, divide, plug it in your calculator as well, divide log of 2, and sure enough, it does come out to be 3. All right, so the change of base theorem truly does work. All right, so on 3 and 4, you're going to evaluate using the change of base. number 3. Log base 3 of 17. All right, so rather than setting it equal to x and wrapping it around, what we're going to do is do log of b, or log of a divided by log of b. So this is going to become log of 17 divided by log of 3. Again, that's instead of setting it equal to x like I did up here and doing all this work. Change of base theorem allows me to do this. Change it to the base of 10. Then I can plug it in my calculator. Log of 17, close parentheses, divide by log of 3. Now this one we couldn't do in our head because 3 to what power 17? It's not going to work. I know 3 squared is 9, and 3 cubed is 27, so it's between 2 and 3. And sure enough, I get 2.579. 2.579. All right, number 4, log base 6 of 0.1, log of the a value, that's the value here, divided by log of the base. Log of 0.1 divided by log of 6. That's how change of base works. So log 0.1, close parentheses, divide log of 6. Negative 1.285. And it's okay to end up with negative answers. Negative 1.285. All right. Moving on to number 5. We are going to be solving here. Solve number 5. 8 to the x equals 214. Now this is where I'm talking about, I don't use change of base here. I use what I did on problems 1 and 2 just because it's clean, it makes sense, we can do it every single time. Whenever I'm trying to solve and there's an x as the exponent, the variables in the exponent, and I cannot get them to the same base, I take log of each side. I will show you using change of base in just a little bit, but right now I cannot get these to the same base. That's my goal, but 2 to no power is going to give me 14. So I'm going to take the log of both sides. Why? Because I want to get that exponent down. So it's just going to be just like numbers like these here, but it's already rewritten in exponential form. So then I do this to bring the x down. X times log of 8 equals log of 214, and then I divide by log of 8 and plug it in the calculator. And again, like I said, I will show you using change of base in just a little bit. X equals log of 214, log 214, close parentheses, divide by log of 8, and that gives me 2.580. Or using the change of base way, you do not have to do, I'm just going to show you after this, you're going to decide which method you prefer. Most times I'm going to do this method when I'm solving something like this. I will use change of base if it's written like this, but when we're solving equations, when we're doing word problems and it's written like this, it's going to get a little messier than this. I'm going to solve it this way here. But here is how change of base works. This is exponential form. Change it to logarithmic form, and you change it to logarithmic form the same way we do the wraparound. But this time you're adding the log. Log base 8 of 214 equals x. Log base 8 of 214 equals x, because 8 to the x power is 214, and that's what they gave us. And then use your change of base, log of the a value, 214, divided by log of your b value, log of 8, and then divide. Log of 214, we did that already. Log of 214 divided by log of 8 equals 2.580. So your choice on which one you want to use. Okay, number 6, e to the 2x equals 12. All right, and I am going to take the log of both sides, but since it is e, instead of taking, well actually, yes, since it's e, I'm going to take the ln of both sides. Why? Because e and ln go together, so ln of e to the 2x equals ln of 12. You could use log base 10, but I'm using log base e. Okay, now I do this to bring the 2x down as a coefficient. Okay, now right here, what does ln of e equal? Ln of e, I'll put a little thinking bubble here. Ln of e is log base e of e. E raised to what power is e? Do you see that? That means log base e of e, and that answer is 1 because e to the first power is e. So this piece right here is a 1 in disguise. So I'm going to change it to a 1, leaving me with 2x equals ln of 12, and I'm going to divide both sides by 2 and plug it in. Ln of 12 divided by 2. Ln, this time using the ln key, 12, close parentheses, divide by 2. 1.242. Now, if you wanted to use the change of base there, you could as well. But I am going to move on to number 7. Find the half-life of strontium-90 if K equals 0.0246, where here's the equation they're going to give to you. A equals A naught times e to the negative KT. And T is expressed in years. T is expressed, so T is your time in years. All right, and we're going to find the half-life. All right, so here's the formula we're going to use. and we're going to find half-life means the amount of time it takes for us to end up with half of what we started with. Okay, they gave us K, and we're looking for T. T, find the half-life, we're looking for the amount of time, that's T, it takes for us to end up with half of what we started with. Okay, so I'm going to write down what's what, because there's a lot of letters here. A naught, this little A sub 0 means A naught, that's your initial amount. That's the amount you started with. A, this A value here, is the amount after time T, after 2 years, after 3 years, after 4 years, and so forth. T is time, in this case, in years. And K, they gave us the K value is there. Okay, so I'm going to plug it in, and we're going to work it out. Okay, so I have, oh, now what do you do when they don't tell you what you start with or what you ended with? Okay, so I'm going to write that down right now. What is A naught and what is A? Okay, so I'm going to put that over here. When they don't give you these, your initial amount, you always make your initial amount 1, and your amount after the given time. In this case, we're looking for us to, the amount of time for us, the amount of time it takes to end up with half of what we started with. So A naught is 1, A is 1/2, T is what we're looking for, and K equals, where's K? 0.0246. Okay, so let's say it said something about how long does it take to triple. A would be 1 and A would be 3. How long does it take for our amount to double? Not on this problem, but we will get to those eventually when we're dealing with growth problems or with money, investing money in the bank. How long does it take for us to double the amount we started with? 1 and 2. Triple the amount we started with? 1 and 3. How long does it take for us to end up with half of what we started with? 1 and 1/2. A naught's the initial amount. When they don't give it to you, you make it 1. And A is a half or 2 or 3 depending on what you're dealing with. In this case, it's half-life, so it's half. All right, so our equation is 1/2 equals 1 times E raised to the, where's my equation? Negative K, so negative 0.0246 T. Okay, at this point, I would divide both sides by whatever that amount is there. In this case, dividing by 1 is not going to change anything, so I'm just getting rid of that 1. It's not necessary because 1 times anything doesn't change. Dividing by 1 doesn't change. So I have 1/2 equals E raised to the negative 0.0246 T. Now, again, you can use the change of base by changing to logarithmic form, but these are the ones where I'm going to take log of both sides and bring down my exponent. But instead of log, I'm going to use ln instead of log base 10 because there's an E in the problem. So ln of 1/2 equals ln of E raised to the negative 0.0246 T. And the whole reason I do that is to be able to take this exponent and bring it down as a coefficient. Ln of 1/2 equals negative 0.0246 T times ln of E. I'm going to move this over here. Okay, so what do I have? I have ln of 1/2 stayed. This green exponent came down here to the coefficient, and then ln of e is still ln of e. But remember what we talked about earlier, that ln of e is a 1 in disguise, because that means log base e of e, and that equals 1. So this is just a 1 in disguise. So I'm going to rewrite it over here. ln of 1/2, and you can change 1/2 to 0.5, it's up to you, equals that there, negative 0.0246 t, and I'm trying to get t by itself, so I'm going to divide by that negative decimal. Negative 0.0246 gone. Negative 0.0246, and that there, this right here, is what I'm going to plug in my calculator. ln of 1/2, ln, I'm just going to type it in as 0.5, ln of 0.5, close parentheses, just like we did before, divided, don't forget your negative key is down here, don't use your minus key, negative 0.0246, 28.177 years. So it takes 28.177 years for us to end up with half of what we started with. All right, that is it for this lesson.